set type up in lines cast from molten metal, first introduced at the close of the last century, are now the most widely used. Automatic typesetting of complete lines. These are the intertype and linotype machines, which are essentially the same, except only in the vast assortment of models designed to perform the particular needs of various types of special jobs. These composing machines produce typecast in complete lines or slugs. Here is a slug or line of type turned out by these machines. The lines of type, properly arranged, make up the page from which, after inking, the imprint or proof is made. The function of the keyboard composing machine is to produce the essential materials required to prepare a form for printing. But before going into detail, let's first get a general view of the whole picture. The operator, depressing the keys, releases matrices from the magazine channel. The matrices are delivered to the assembling elevator in the correct sequence. Here's a close-up of some mats. You can see the letter that has been punched or engraved into which the molten type metal is going to be injected. Let's note particularly the two punched characters, one Roman in style and the other italic. The small lugs and the ears which guide the mats through the various passages and assure the alignment of the letters. Having completed the composition of the line of matrices, the operator sends it over to the casting mechanism. Now the line of matrices is in position for the slug to be cast. Against the opening of this mold, the mat will fit perfectly. Immersed in the crucible, the plunger injects the molten type metal into the mold and against the matrix characters. The metal solidifies, forming letters and symbols in relief. Then the slugs are carried into position to be ejected from the mold and stacked one after another as they are ejected. Meanwhile, the first elevator rises and the second elevator descends to meet it at the transfer channel. The matrices are transferred to the second elevator and raised to the distributor. Here, lifted automatically, one at a time, they are returned to their respective channels in the magazine. These circulating matrices will be used over and over as they are needed for composition. Using this simple sketch of the machine, let's go over the various steps already seen. The mats, responding to the keyboard, are delivered to the assembling elevator. The line of matrices is sent to the casting unit. After the slug has been cast, the matrices are carried by the elevators and transferred for distribution. The operations necessary to produce a slug or line of type are divided into three groups: composition of the matrix line, casting of the slug, distribution of the matrices. Let's now analyze the operations in the first group, composition. Regarding composition, the principal parts are the keyboard, the magazine, the assembler entrance, partition, the matrix delivery belt, the assembling elevator, and the delivery slide. The keyboard has 90 keys on 6 rows of 15 each. It is divided into 3 sections. The lowercase letters are at the left, uppercase in similar arrangement at the right. At the center, punctuation marks, numbers, and small caps. Every touch of the key releases the required matrix from the magazine. Now we will examine the internal parts of the keyboard activated by one touch of a key to release a matrix from the magazine. They are the key button, the keyboard lever, the key bar, the trigger, the cam frame, the eccentric cam, the rubber roller, the comb, and the key rod. Let's observe how the various pieces react to the key. The key moves the lever to which it is joined. This lifts the key bar. In turn, the key bar activates the trigger, whose function it is to support the frame with its corresponding eccentric cam. The motion of the trigger allows the frame to lower itself so that the cam revolves around the rubber roller, which rotates continuously. The rotation of the cam lifts the end of the frame. This raises the long key rod, which causes the release of the matrix from the magazine. Similarly, we find on every machine, corresponding to the keys, 90 key rods, which make up the assembled key rod frame, which is situated behind the assembler entrance and brings the keyboard into play with the magazine. Here are the upper ends of the key rods, which rock escapements situated in the magazine, thus allowing the mat to be released. Let's study this operation more closely. The upper end of the rod transmits the movement to a half-moon-shaped device called the escapement. The two ends of the escapement are called lugs. Penetrating the magazine, they control the release of the matrices. The mat in the first row is held up solely by the front lug of the escapement. As the key rod lifts, the front lug of the escapement lowers, releasing the first mat. At the same time, the rear lug is lifted and holds the second matrix. As the key rod lowers, the spring returns the escapement to a position of rest, thus allowing the second mat to move forward in the place of the one released an instant before. The same operations are repeated at every touch of a key. The mats that we see come out are arranged in the magazine situated at the upper part of the machine. It rests in a slanted position to facilitate the descent of the mat. It is substantially formed by two trapezoidal plates, one below and one above, which, as in our case, can be made of visilite. On the inside of the magazine there are grooves called channels, which support and guide the circulating matrices. The magazine has 90 channels, corresponding to the 90 keys on the keyboard. Every channel contains a maximum of 21 circulating mats, which are sufficient for the normal requirements of composition. Generally, a mat carries two letters, Roman and italic, or Roman and bold. A magazine contains lowercase letters, Roman and italic, controlled by the left section of the keyboard. The uppercase letters, Roman and italics, controlled by the right section. The small caps, numbers, and punctuation marks controlled by the middle section of the keyboard. In changing to another type, larger or smaller, the magazine must be changed. Similarly, in going to another series or letter design. It is precisely for this reason that machines are built with a capacity of up to 4 movable magazines, any of which can be replaced with others. The pre-selected magazine is brought into working position with the escapement aligned over the key rods. The mats released from the magazines are now directed toward the assembling elevator. Now we'll see the whole operation in slow motion. They are guided in their descent by the assembler entrance partitions, which prevent them from turning out of correct position. The mats fall upon a delivery belt in constant motion, which carries them in correct sequence to the assembling elevator. It takes the same length of time for all mattresses to reach the assembling elevator due to the design of the assembler entrance and matrix delivery belt. Before reaching the assembling elevator, the mats have to pass under a small spring blade called a chute plate, which cuts down its speed so that the rotating star wheel can turn it upright and move it forward against the others in the assembling elevator. At the left, the mats are held upright by a wedge or a finger attached to a long horizontal bar called a slide, which travels to the left as fast as the mats arrive. The assembling elevator consists of a front and a back plate. When fastened together, they form a channel in which the mats can assemble. These moving levers control the duplex rail. With this device, the mats can assume 2 positions in the assembling elevator. Mats in the first position, Roman, rest on the fixed lower rail. Mats in the second position, italic or boldface, rest on the movable duplex rail. Hence, each mat can present independently to the mold opening either one of the 2 characters. Here is a line of mattresses which illustrates this principle. For greater convenience, the upper part of the assembling elevator is equipped with a hinged gate. A steel wedge known as a spaceband is assembled between one word and the next. The spacebands are released by the key situated at the left of the keyboard. Because of their dimensions, the spacebands cannot fit into the matrix magazine. Therefore, they are stored in a box above the assembling elevator. The parts for releasing the spaceband are similar to those which release the mattresses from the magazine. The spaceband consists of 2 parts, the tail, the slide, and the small head. Both are wedge-shaped. They are held together by a dovetail construction. The small head is held stationary by the lugs in the grooves of the first elevator, so it remains fixed when the corresponding slide rises. In that manner, the expansion of the spaceband is obtained. Whatever the position of the slide, the outside surfaces of the slide and head are always parallel, due to the construction of the parts. The function of the space bands is to expand or spread out the line to the predetermined length, thereby increasing the space between words evenly. This is called justification. Having completed the line and checked that the number of space bands is sufficient for the amount of expansion needed, the operator can send it to be cast. The transfer is carried out by the delivery slide, constantly held under tension by a spring, and held in place by a small lever which will be released by the raised assembling elevator. The delivery slide consists of a short fixed finger and a long moving one. They receive the line and carry it through the transfer channel to the first elevator. At this point, we end the operations of the first group and take up the second, the casting. Note that the casting unit starts operating automatically as each matrix line is delivered. It takes from 5 to 10 seconds for a complete cycle, depending upon the speed of assembly. All the while, the operator continues to compose. Let's go into the explanation of this group. A 1/2 horsepower motor supplies the drive transmitted by a large pulley through a transmission gear and belts. Many of the basic mechanical actions of the machine depend on the 10 large eccentric cams situated at the rear. With a series of springs, they make up a completely automatic setup. These eccentric cams are synchronized to rotate together, since they are all mounted on the same shaft. The cams begin to rotate as soon as the delivery slide carries the matrix line into the first elevator jaw. This releases a stop in the delivery cam at the rear of the machine. The 2 friction shoes of the driving clutch are then pressed against the inside of the driving pulley, thus causing the driving shaft to rotate the cams. At the opposite ends, this shaft has a pinion that transmits the movement to the large driving gear on the cam shaft. The cams are thus made to rotate. Every complete turn of the cam shaft corresponds to the casting of a slug. Every eccentric cam has a specific function which it carries on during its cycle, quite independently of the others. To get an idea of how the cams work, let's observe the first of the series that controls the first elevator. The first cam, by means of the vertical lever, on a pivotal mount, and the long horizontal lever, which runs through the base of the machine, transmits the movement of the first elevator. Every turn of the cam corresponds to a determined movement of the elevator, as we see in the close-up combination. The cam makes the elevator descend to the vice cap and holds it in casting position. The cam next raises the first elevator to the intermediate channel for the transfer of the mess. Then the cam permits the elevator to return to normal position. Here are the other parts which, with the cams, make up the casting: the vice frame, the mold disc, and the metal pot. This is made of an outside casing or jacket and provides thermoelectric insulation to the crucible that contains the molten type metal. Between the casing and the crucible, there is a cavity stuffed with asbestos. The plunger is in the well of the crucible, at the front of which there is a mouthpiece. When the plunger descends, it drives molten metal into the mold against the matrix line, thus casting a slug with the letters in relief. The type metal solidifies almost instantly. Then the plunger rises again to normal position and sucks molten metal into the well to replace what was used up in the previous casting. Automatic feeding regulates the descent of the metal pig to maintain a constant level of the molten metal in the pot. This metal is a triple alloy composed of lead, 85%, antimony, 11%, tin, 4%. The temperature for casting, approximately 285 degrees centigrade, is kept constant by a thermostat. The metal pot is always kept heated so that it is ready to cast slugs each time the mouthpiece moves forward and locks against the back of the mold. The mold is mounted on a rotating disc. The disc has teeth which are geared to a pinion activated by two sections of gears, so that it rotates at intervals. Normally, the wheel carries 4 molds for casting. The mold is made up of the following parts: the body, fastened to the disc with 4 screws, the cap. Between the body and the cap there are inserted, depending upon the production needs, the precision liners, constant length at the right and variable length at the left. The liners determine the length and the thickness of the slug. Therefore, the purpose of the mold, as the word shows, is to establish the dimensions of the lead slug, which may vary in length and in thickness. To avoid constantly changing the liners, there are usually 4 molds mounted on the disc. Naturally, only one of these is pre-selected for a given job and must be in vertical position at the right. Behind this mold is situated the ejector, whose function it is to expel the slug at the right moment. To avoid overheating of the mold, in certain models, water is made to circulate on the inside of the disc, as we can see in this diagram, while in others, the same effect is obtained by air blower. In front of the mold disc, there is the vise frame that can be opened when necessary. Important parts of the vise are the first elevator, the vise jaws, the justification block, the knife block, and knives. The first elevator jaw is so arranged as to receive the line of mattresses from the delivery slide and to lower the line between the 2 vise jaws. The jaw at the right is fixed, while the one at the left is movable. The latter, set in advance, determines where the left end of the matrix line will be positioned with respect to the mold opening. The justification block, driving the spaceband wedges upward, spreads out the line of mattresses. 2 vertical knives trim the sides of the slug. 1 knife is movable and the other stationary. The movable one is adjustable in advance according to the type size called for. After pointing out many parts involved in casting, it will now be easy to review the operations involved in the casting of a new slug. The elevator lowers the matrix line between the vise jaws. In the meantime, the mold disc makes a quarter turn to put the mold in position for casting. It advances slowly to engage the lugs of the mat in the alignment grooves of the mold body. The justification block raises the wedges of the spacebands, which expand themselves between the words and spread out the line. The metal pot advances against the mold, locking the mouthpiece tightly against the mold and the mat. This is the instant in which the plunger injects the molten type metal into the mold under pressure, casting the slug with the letters in relief. The plunger rises, the pot and the disc retract. The justification block comes down. The mold disc starts its 3/4 turn, during which a knife, located behind the disc, trims the base of the slug, bringing it to exact printing height. Now the ejector blade forces the slug between the 2 vertical knives, which trim it on both sides. Then it falls into the galley. Immediately after casting, the first elevator carries the line of mats to the second elevator. Now, the casting operations completed, the distribution operation begins. Now the line of mats is aligned with the tooth bar of the second elevator, which has seated on the transfer channel. The transfer finger, moving the mats toward the right, forces them from the first to the second elevator. The mats glide onto the second elevator bar and remain there, suspended by their teeth. As soon as the transfer has been completed, the elevators return immediately to their normal position. The space bands, which do not have teeth, remain in the transfer channel. During the second closing of the transfer levers, the spaceband pawl engages the spacebands and returns them to the box. The distributor shifter retracts, allowing the second elevator to seat at the distributor. Then the shifter pushes the mats into the distributor box. Here the mats are raised, one by the matrix lift. The slight lift is sufficient to insert the mats into the coils of the 3 helicoidal screws. It should be noted that it is not the function of these screws to keep the mats suspended, but only to push them ahead. The 2 upper screws engage the ears of the matrix, while the lower one engages the lower front lug. To keep the mats suspended up to the moment of their release into the magazine is the function of the distributor on which they glide, suspended by their combination teeth. Every mat is therefore supported on the distributor bar by means of their teeth, as we can see here. For example, the mat of the letter O will remain suspended on the bar with the second and third tooth combination. This other one, however, corresponding to the letter N, will remain suspended with the fourth tooth combination. When the distributor bar fails to supply the required combination, the mat, no longer having support, drops into the magazine. Therefore, for the 90 magazine channels, there are 90 different tooth combinations, and consequently, an equal number of combinations along the length of the distributor bar. The mats, detaching themselves from the bar, return to their respective channels in the magazine. Those mats which do not run in the magazine have all of their teeth so that they run the entire length of the distributor and drop into a chute which guides them into a stacker near the keyboard where the operator can select them and insert them as needed in the assembling elevator. Let's now review the entire procedure at a glance. The manipulation of the keys releases the mats from in the magazine. They drop between the assembly entrance partition and are delivered to assembling elevator to form the line. The finished line is sent on to the caster. The mold and the metal pot advance, and the plunger makes the cast. The pot and the mold withdraw. Then the first elevator rises to transfer the mats to the second elevator bar. At the same time, the slug, trimmed at the base and sides, is ejected into the galley. The mats go to the distributor. Moved by the helicoidal screws, they run along the length of the distributor bars so that, with the procedure already noted, they fall into the respective channels of the magazine, ready for use in succeeding lines. As in all industries, technical progress has achieved notable progress in mechanical composition. Here's a sensational one. This machine has been made completely automatic, so that it is not necessary to have an operator touch the keys. The keys are actuated by a tape, perforated in code. This system, known as a teletypesetter, is based upon the principles of the teletype, used in many newspapers both in Europe and in America. The ribbon is first perforated by a machine with the keyboard almost like that of a typewriter. At every touch of the keys, code perforations are made on the tape, which are aligned vertically and numbered from 0 to 6. These two perforations correspond to the letter A. The letter B has 3 perforations. The letter C also has 3 perforations, but different in position. D has 2, E only 1. 3 perforations for the letter F, and so on for all the other letters and symbols. The small central perforations serve only to move the ribbon forward. At the same time, the widths of the mats and spacebands are total on the scale on the quadrants. When the line is finished, the keys are hit for the return of the indicator. Thus perforated, the ribbon is applied to the so-called automatic operator, situated at the right of the keyboard of the composing machine. The reading of the perforated tape is accomplished by the automatic operator, a true jewel of engineering, usually 6 small feelers in series with the perforation. It is interesting to observe how only the small feelers, which go through the perforations in the tape, transmit the movement to the keys of the composing machine, which translates the codes without error at a top speed of 20,000 letters an hour. Note that the raising of the assembling elevator is also automatic. This is the performance of one of the numerous composing machines which, with increasing rhythm, accomplish the important task of preparing composition for newspapers, periodicals, books, and printing of all kinds in all European languages and in some Oriental